everyone, in this video I'm going to discuss about my AWS ECS code with Terraform, and here also I deployed 6 services in single load balancer and with Terraform. So I also created a CI/CD pipeline for 6 services. Firstly, I'm going to discuss about my VPC. So VPC is a virtual private cloud. Is a virtual network dedicated to your AWS account. It is logically isolated from other virtual networks in the AWS cloud. You can specify an IP address range for the VPC, add subnets, gateways, and associate security group. So this is my security group code, as you can see. So a subnet is a range of IP address in your VPC. You launch AWS resource such as Amazon EC2 instance into your subnets. You can connect a subnet to the internet, other VPCs, and your own data center, and route traffic to and from your subnet using route table. So this is my association of a route table with my subnet, and so now next I am going to discuss about a little bit of my security group. So security group is a security group actually controls the traffic that is allowed to reach and leave the resources that is associated with. For example, after you associate a security group with an EC2 instance, it controls the inbound and outbound traffic. So there is inbound ingress and outbound egress traffic for your service. When you create a VPC, it comes with a default security group. So that's all about in my security group. It's actually a control of traffic that allowed to reach and leave the resources. So next there is a S3 bucket. Now this is a resource of my S3 bucket, and the main working of this S3 bucket is it is an Amazon simple storage service, and is an object storage service that offers industry leading scalability, data availability, security, and performance. Customers of all sizes and industries can use Amazon S3 to store and protect any amount of data for a range of use cases, such as data lakes, websites, mobiles, applications, backup and restore, archive, enterprise application, load device, and big data and analytics. Amazon S3 provides management features so that you can optimize, organize, and configure access to your data to meet your specific business, organizational, and compliance requirement. That's why we use this S3 bucket, so that we can store all your artifacts in it. Now this is the name of my resource artifacts bucket name, and this is my name of my actual bucket. That now force destroy true, so that after using Terraform destroy, it will destroy my bucket. And ACL private, now in tags I give a name my Terraform bucket. That's all in my. Now next there is a resource of my cluster, and this is a common cluster of my every services, 6 services. Now what is a cluster? Cluster is a Amazon ECS cluster. It is logically a grouping of tasks and or resources, or services. If you are running tasks or services that use the EC2 launch type, a cluster is also a grouping of container instances. So if you are using capacity provider, a cluster is also a logical grouping of capacity providers. So this is a main reason of making this cluster. So after that there is a load balancer and target group. Now this is a listener and target group of my service 2 this is a second and third and fourth, and like that I have created 6 services. So my target group should be 6, and also listener should be 6. So this is all in my common.tf file. Now next I'm going to discuss about my cluster, and this is a ECR. ECR is a Amazon Elastic Container Registry, and Amazon ECR is an AWS managed container image registry service that is secure, scalable, and reliable. Amazon ECR supports private repositories with resource-based permissions and using AWS IAM. So I created this 6 ECR. You can also create your one repo under which you can store your 6 images, Docker images, but I create 6 ECR so that it should be more clear for all and for me also. So I created 6 ECR repo, and under which Docker image should be there. So under data.tf there is a role of my task execution. So this is a role of my task through a console I created in my AWS. So you have to create your AWS if you are using data.tf. So in IAM roles I created code build role and code build policy, and also my code pipeline role and code pipeline policy. Now next, firstly you have to, if you are using Terraform, you have to create your provider.tf. So that's how, as you all know. So first there is a service 1 of my pipeline. This is a pipeline of my service 1. Firstly I have created this task definition. To use it doesn't really matters which instance tasks run or so long as they run. A service configuration references a task definition. A service is responsible for creating task. So that's why we firstly we create a task, then we create a services, so that under task definition, with the help of task definition, we can create a service. So services are typically used for long running application like web servers. For example, if I deployed my website powered by Node.js and I want say at least 3 tasks running across the 3 availability zone. So for the sake of high availability, if one fail, I have another 2, and the failed one will be replaced. So creating a service is the way to do this. So if I had 6 EC2 instances in my cluster, then 2 per the service will automatically balance tasks across zones as best it can, while also considering CPU, memory, and network resources. So this is our main reason that we created task definition services. So this is a first service and first my CI/CD pipeline. So this is a source in my pipeline. Firstly, this is my resource of my code build of my first pipeline. Now artifacts, this I used S3 bucket. This is a resource of my pipeline. This is very important. So resource, in under resource there is a type, location, and this is a type in GitHub, and this is a link of my HTTP link of my repo, and that is present in my GitHub. So this is my pipeline, code pipeline. Now I attached a role of my pipeline that is present in my IAM roles. So artifacts, S3 bucket. Now source, there is a source of my GitHub version 1. Now owner, this is owner of my GitHub repo. Now this is a repo name, branch main. This is my token. This is a build of my pipeline and deploy. So now the build stage is a first stretch of a CI/CD pipeline, and it automates steps like downloading dependencies, installing tools, and compiling. Besides building codes and build automations includes using tools to check that the code is safe. And build, there is a name, I mentioned build name, in category owner, that's how it's this syntax of build is name my docker build. So next there is a deploy, and deployment pipeline. In pipeline there is a deployment pipeline is a process of taking code from version control and making it readily available to user of your application in an automated fashion. So when a team of developers are working on projects or features, they need a reliable and efficient way to build, test and deploy the work. Historically, this would have been a manual process involving lots of communication and a lot of human error. How it's represents, so this is a main syntax, and this there is a honor like this. This is a cluster name, service name, file name, cluster name that I created, and the service one. This is a pipeline of my service one, so this name of my service name is service one. Now file name is service1.json. So like that, there is a autoscaling target. Now there is a policy I attached. Now this is a scale down policy, CPU high, CPU low. So that's how my first pipeline is create code is terraform code of my first pipeline. That's how I create another 5 pipelines also with the same process. So in my var.tf there is a my deployment environment, and there is a this is my resource variable of my S3 bucket. I have mentioned here 2 of them. Now next I have to explain of my build spec.yml. This is very important, so I'm quickly explaining this so that my pipeline should work well. Without this my pipeline shouldn't work. Now firstly I am explaining build spec, what it is. It is in this step you create a build specification, build spec file. Build spec is a collection of build commands and related setting in YML format, and that code build uses to run a build. Without a build spec, code build cannot successfully convert your build input into build output, or locate the build output artifacts in the build environment to upload to your output bucket. Now create this build spec. Firstly there is a version representation. So as you can see, here is a version 0.2, and version represents the version of the build. Phases representations the build phases during which you can instruct code build to run commands, and these build phases are listed here as install, pre-build, build and post-build. So you cannot change the spelling of these build phases names, and you cannot create more build phases names. And during this build phase, code will run the commands. So these commands instructs compile, test and package the compiled data classes files into a build output artifacts. For completeness, a few echo commands are placed in which build phases. Now the output of these echo commands can help you better understand how code will run. For each build phases, code will run each specified commands one at a time in this order listed for being to end. Now there is a in last there is a artifacts. Artifacts represents a set of builds output artifacts that code build uploads to the output buckets. Files represents the file to include in the build output. The code build uploads the single message defined file found in the target relative directory in the build environment. The file name service1.json. This is all my service, that's why I name this service1, service2, service.json. And this is my build spec representation. Now this, so here I mention my path. -f means find. This is a path of my git repository, and this is under my file there is a file name. Now here I given a path of my docker file. So with the help of -f is find and service1 docker file. This is a repo in which my service1 and docker file is. So I give path of every services of my 6 services. So in post build the docker push command, with the help of docker push command all my docker images will push. In post build push will done. Now next there is all my images that is present in pre-build. It will post all images into post build phase. So this is my service.json file artifacts. So that's all about in my build spec. So next I am showing the output of my this terraform code. So here it is. Here I am writing a command terraform init. So initializing. Now it's done. Now next command I try apply terraform plan. So it created a blueprint for my terraform code. Of my terraform code, all resource will done. So terraform apply will apply my all terraform code. So it's creating in my AWS account. My all resource will create. So it's successfully done. Now I'm showing you in my pipeline. So my 6 pipeline is successfully done. So this is my 6 pipeline, and source is done and build is in process. So it's done. My all 6 build is done. As you can see my all 6 build is done. Now its pipeline is 3 stages is done successfully. Now it's my pipeline. This is my 6 pipelines. So next I am showing you elastic container service. So this is my cluster, and inside my cluster there is a 6 service and 11 running tasks. So this is my services 1 2 3 4 5 6. Now inside my services there is a task. So as you can see 11 tasks, because in my desired task I selected 2, so that's why it's came 11 tasks running. Now next I am writing a command terraform destroy. It will destroy all my resources that is present in my console AWS. So it destroy all my resources, but only ECR I need to destroy it from my console. Rest, as you can see, rest is destroyed, but only ECR is there, so I destroyed through console. So that's all about in my, so nothing is there. ECS is destroyed successfully.